Hi everyone. Today's topic is complex numbers, and we are going to cover a couple things. We're going to start with writing imaginary numbers using I. In this section, we learned about imaginary number systems in which square roots of negative numbers are expressed using a notation involving the letter I. Any square root of a negative number can be rewritten as a product of a real number and the imaginary unit, which we express as I. Imagine unit, the number represent I, where I equals square root of -1 and I squared equals -1. So this one is I with no power, which is I to the first power, square root -1. I to the second power is -1. Okay, one of them square root, the other one is square. This one is square root, this one is just -1. Now think about it. If you square both sides, square and square root cancel out. That's why it's written that way. And we're going to come back using that idea a lot. Then the next one, an imaginary number. Now here's the unit because it's I. Imaginary number, a number that can be expressed in the form of B times I, BI, where B is a real number, which is like a 2, and I is an imaginary unit. So it's going to be a real number and the unit of imaginary number. B is real number and I is imaginary unit. So the first thing we're going to start example 1, write each imaginary number as a product of a real number and I. And the only thing you really have to do is you can actually do square root of -1 times square root of 9. Now we know the rules on before. Square root of -1 right here, I is equal to -1. So in this case, square root -1 I and the square root of 9, 3. 3, I'm gonna write it in the proper position and you guys can see. This is I times 3. Now we usually do not like to put the I in the front because we might get confused. So we switch around, the number always in the front. So it's 3I. And that is your answer. So for letter B, the first step, you guys should know how to do it. Square root of -1 and times square root of 54. Now square root of 54, we have done this over and over from before. So it's going to be square root of 54. Break it down. That's going to be 2 and that's going to be 27 and then 3 and 9 and 3 and 3. And you get a pair of 3. So that's going to be switching the numbers around. So it's going to be 3 root 6. And then the -1 right here is going to be just negative. It's just going to be I. So we usually put it properly is the I going to be right after the number. So it's going to be 3I root 6. We don't put the root after the I. We don't put the I after the root because you are supposed to take it out. And sometimes you guys does not write the I properly. So it look like underneath you might. So for that purpose, we always have it attached to the number at the end before the square root. So the letter B is going to be 3I square root of 6. Go ahead, try C and D. So for letter C, it's a square root of -64. So what I have done is I put the 64 in the front because, now we really have to understand 8 goes in the front and the negative square root -1 goes in the back. So I thought I just write an 8I that way. It will be easier. So if you want to from now on put down your square root of -1 in the back, that's totally okay with me. You can put it in the front, you can put it in the back. Just don't forget you have an I when you have a square root -1. The next one, I also put it in the back again. So that's 48 and that is square root of -1. Now breaking down square root of 48 is going to be divided by 2 pairs. That's going to be 4 and the 3 goes inside the I right here. I bring it down, give you guys a arrow so you know where the number should go. And that's example number 1. On to the next thing, complex number. A number that can be expressed in an A plus BI. The problems previously will only do the BI part. Now we are doing a number plus BI, where A and B are real numbers and I is the imaginary unit. We have an expression with 2 terms. So that's a binomial terms. So when A equals 0, now let's think about this. A equals 0, right here, 0 plus BI. What do you have? You only have complex number, purely imaginary number, because this drops out. So you only have BI. If B equals 0, the complex number is a real number. If you have A plus bi. And then a plus b, which is 0 times I. Well, anything times 0 is 0. So a plus 0, you get a, which is real number. And then b is real number. So that's the next one for complex number. There's two different forms. On to example number 2, adding and subtracting complex number. Now, when it's come down to this kind of problem, I would like you to think about your x is like an x, just a variable. If you can think about it that way, it will make everything so much easier. So to start off, the letter E, negative 8 plus 7i, that is going to be just negative 7i plus 5 minus 19i. Pretend they are a variable. Negative 8 plus 7i plus 5 minus 19i. And combine like term like they are x or any variable. So that's just negative 3, because if you cut them, that and that gets combined, negative 3. Then the next one gets combined because they are like a letter. So that's a plus 7i minus 19i and negative 12i. And that is it. That's your answer. I hope that's easy enough for you guys. Please pause the video and try letter F. Now, don't forget, letter F has a negative sign. You'll have to make sure you distribute a negative. All right, try it. For letter F, I just distribute the negative sign, and that's going to be negative a plus 3i, and negative 1 and negative a gives me negative 9, plus 13i and plus 3i gives me positive 16i. Example number 3, now we are multiplying complex number. Now this is where the little tricky part comes in. Remember from before, we have something that says if you have I squared equals negative 1. I squared equals negative 1 is the rule we're going to follow here. So let's take a look. I squared equals negative 1. Now, what does I squared mean? Well, I squared is really equal to I squared is equal to I times I. That's two of them. I squared literally is just like the letters. All right. So because of that, we're going to take a look at what's going to happen. Here's 9 times 8, and then they both have I. So you just do it like you usually do. Multiply the number and take care of your exponents for the I. So that's going to be 72I squared. Now, you know I squared right here is really I times I, and I squared equals negative 1. Now, because this step right here, that makes all the difference, equal to 72, that's I squared. And that's really 72 times negative 1. Eventually, you don't have to write this step. That is unnecessary. You can go directly from this step to here or even to your answer. So in this case, that's just negative 72. And that's your answer for the problem for this one. Here's the answer, negative 72. H. You need to distribute property, so works the same way like what you do. Don't forget H is just distribute property. Pretend I is like an X again. So that's going to be 20I, 5 times 4, and then I comes with it. And then 5i times negative 7i is negative 35i squared. And because that's I squared, I need to recognize I minus 35 times a negative 1. And then in this kind of steps, I usually like to write it down because then I realize, and in parentheses, I realize 20i negative times a negative is going to be a positive 35. And this is just a complex imaginary number because I have a 35 in the back. So there is your answer, and that is it. Okay, so that's letter H. Now we have the next one, I with binomial times binomial. Again, this is the same kind of thing. It's like FOIL, or you can just do the first term times the second parenthesis, everybody. And you have 8 times 2 is 16. 8 times positive I is going to be plus AI. Then I am going to do the next set, and then the next set is going to be negative 3I times 2 and negative 3I times I. So that's going to be negative 6I, and that's negative 3I squared. Now we are going to do a couple things. So we're going to have to combine like term and change my negative signs. So you have 4 terms. So you can add the 16 and the eventually you can see something real quick. 8i positive negative 6i gives you plus 2i. Then minus 3i squared become negative 1. I squared negative 1. All right, now I'm going to combine. So that becomes 16 plus 2i plus 3, and that is going to be 19 plus 2i, and that will be your answer for this problem. Please try example letter J. To take a look at this problem, you have 36, which is 6 times 6, 36. 6 times 5i, that's plus 30i. Negative 5i times 6 is negative 30i. Negative times a positive give you negative 25i squared. I squared become negative 1. Positive 30i and negative 30i cancel each other out. 36 come down. That's 36 plus 25, and therefore it's 61. That's letter J. Next one is complex conjugate. I hope you guys remember conjugate from before. A conjugate is the complex conjugate of a complex number. A plus bi is a minus bi. And why this is important? Because eventually we can take that I and make it a real number. And that's why, because bi will be squared. It's going to be a squared minus bi squared. So therefore the I will be gone. So it's kind of important that you understand what's conjugate. The middle number just changed. Positive become negative, negative become positive. So now the conjugate for example number 4 is going to be 4 minus I. Now if you multiply this out, it's going to be 4 times 4, that's 16. 4 times negative I minus 4I. And then right here, that's going to be positive 4I. And right here is going to be negative I squared. And that's why you noticed negative 4I, positive 4I cancel out. And you only have 16 minus the I squared is going to be a negative. So minus a negative 1, that is 16 plus 1 equals 17. And that will be your answer. Please take a look at letter I and try it yourself. So here's letter I. When you look at letter I wrote down the conjugate. There's the negative sign, there's the positive sign. 9 times 9 is 81. 9 times positive 7i is positive 63i. Negative 7i times 9 is negative 63i. Negative 7i times positive 7i, that's going to be negative 49i squared. 81 is right here. Negative 49 is right here. I squared is negative 1. Negative, negative become positive. 81 plus 49 is 130, and that is letter I. Example number 5, dividing complex numbers. Now, why is it important to divide complex number and we want to deal with it? It's because there's an imaginary number. We don't know how to do it properly. So the only thing we're going to do is just get rid of it. Now, how do you get rid of it? It's actually literally just like a fraction problem. What we're going to do is we are just going to multiply the top by I, the bottom by I. Now, why is that? Well, because that will give me 9i over 2 times negative, 2 times I squared. I want to write this step down. I squared. Well, what's I squared? Don't cancel it because we are going to have an I squared. So that's going to be 9i over 2 times negative 1. You will take care of negative 9i over negative 2. And to write it properly, that's just going to be, to write it properly, the answer is just going to be equal to negative 9 over 2i. And that's your answer for the problem. Please pause the video and try letter I. This is the I example. You have to multiply top and bottom by I, because I give you I squared, and I squared gives you negative 1. And that's our goal. We want to get rid of the i's in the denominator. So when you have simplified way of writing it, we're going to bring the negative 3 to the side, and then I just left. So you have negative a over 3i, and that's actually a problem that is imaginary unit right there. All right. And then let's try, pause your video and try letter J. So for letter J, you can multiply top and bottom by the I right here. And then that's 15i times 5i squared right here. And then 15 and 5 cancel out. That gives you 3. And then I goes on top, I squared goes on the bottom. And that's just equal to, because they cancel out, negative sign goes in the front, that's negative 3i. And that's the answer for letter J. So letter J, letter K is the same thing. Letter K is going to be 4 over 2i plus I over 2i. And what you're going to have is you're going to cancel out first and then see where you are at. So 4 and 2 cancel out. That gives you 2 on the top. And the I cancel out. So the answer is really 2 over I plus 1 over 2. Now we usually like to put the number in the front, so we're going to put the half in the front plus 2 over I. Now 2 over I, you cannot have that, so you're going to multiply top by a I, bottom by a I. And then when you do that, that's going to be equal to half plus 2I over -1. And because of that, that's going to be half minus 2I, because couple things, you have negative and positive become a negative, and 2I over 1 is just 2I. So that will be your answer for this letter, half minus 2I, and that's letter K. Now the next one is something that I see on ACT and SAT from before. So I just want to make sure that you guys really know this. Now remember from before, we have I to the first power, and I say, hey, don't forget that's just I. Or you have another way of saying it. I is equals to -1 right here. I equals -1. So we are going to be going down there and making sure that we understand that, right? This is equal to I, or this is equal to square root of -1. And I square, we just did a whole bunch of problem, that's just 1. Now think about it. If you have just scratch work right here, I equals square root -1. If I square it, isn't that the same thing? Is the what the problem we have? I square equals, so now here is square and square root cancel out. That's why we get the -1. Okay, so you need to think about where it comes from. I don't want you to totally memorize it. This is just a little side note right here. Now I to the third power is really I to the first power times I to the second power. So what's I to the first power? Well, I to the first power is just I, okay? That's fine. Or square root -1. But square root -1 is a little bit useless because we don't want square root. Well, what is I square? Well, I square, I know is going to be -1. -1 times I is just -I. So square root of 3, I to the third power is just -I. So let's go back again. I to the first power, I, or square root of -1. I is what we want. I to the second power, -1. I to the third power was -I. It's right here. -1, I. I to the fourth power is really I to the second times I to the second. Well, what's I to the second? I told you guys that already. -1 times -1, and that's going to be 1. So that is your 4 ways of figuring out what is the number. Now, why is that important? Well, the reason those are important is those are your formula that you are going to generate. I to the first power is just I to the first power, just I. That totally makes sense. I to the second power, you just learned, -1. I to the third power is I and -2 I to the second power. So it's really I times -1, just -I. I to the fourth power is -1 times -1, which is +1. That's what you're going to remember. So now to do the problem, MNOPQR is what you have to remember which one is going to be. So how do you do that? Well, every single time you do a rotation, it's like this is the quarter, $1. Okay, so what we're going to do is we are going to figure out how many quarters we're going to get. So 25 divided by 4, and then that's 6. Or you can use a calculator, and that leaves me with 1. I got 6 rotations of 1. And then my answer left over that's not in rotation is I to the first power. What's I to the first power? Just I. There's your answer. Then we're going to take 43 divided by 4. That's 1, 4, 3, nothing. So therefore, I have 10 sets of 4s. I have 10 sets of 4s right here. Then this is a 3, so that's really I to the third power. And what's the I to the third power? -1. So pause the video and try a few problems. Now, one thing I want you guys to also remember is this is a negative sign. And when this is a negative sign, remember your answer is going to get flipped. So that's going to be 1 over I to the 14. So please do it that way. All right, please try the rest of the problems and check back with your answer. So for example O, I have 82 divided by 4, and then that's going to give me 20, and I have 2 leftovers. And because I have 2 leftovers, that's I to the second power, and I to the second power is 1 right here. I to the second power is negative 1. Then you have next one, flipping the negative sign over. That's 1 over I to the 14. And when you divide, I have 2 leftovers. That's 1 over I squared is negative 1. And 1 over negative 1 is negative 1. The next one right here, it's a little bit trickier, but if you think through the rules that we have done, you understand what we did. So it's 1 over I to the 33 power because negative exponent. So we flipped it over. And then 33 divided by 4 is going to be 8 times. That gives you 32. And 1 left over. So it's 1 over I to the first power. And I to the first power is just I. And then because we cannot have an I in the denominator, I multiply top and bottom by an I. So the I goes on top. I times I is I squared. Just in case you guys need that part, that's going to be equal to I over I squared. And I squared is going to be negative 1. And because I squared is negative 1, what I did is I say that's the same thing as negative I. There's your answer. And for the next one, I also did the same thing. I flipped the problem over. So here is negative 47. And that's 1 over I to the 47 equals 1 over I to the third power because I divided by here. And that's going to be 11 rounds of 4 ones, and that's going to be 3 left, and then that's I to the third power. That's 1 over I to the third. I to the third is negative I. Sorry about that. And then because it's negative I, we need to multiply top and bottom by I, and then what you have here is going to be I over negative 1, and that's going to be negative right here is going to be positive. So that's going to be a positive I. And that's your answer. And that concludes the notes for today about complex number. That concludes the notes today. Thank you so much for watching.